Let's look at some of the commonly used Oracle SQL statements used in data analytics.
We had looked at querying data from a single table. We have used different functions, including analytical functions, which is extensively used in building up the SQL query. It so happens in the database, the tables, you'll have multiple tables because you will have a normalized database. So you have multiple tables. And by the way, why do we require multiple tables? I mean, I discussed that point earlier as well. If you have it in a same table, the data, there could be data redundancy. You will keep, having the same data over and over again. So to avoid data redundancy, you need to have a normalized, generally a normalized database. It is more normalized in an ERP application, whereas in a data warehousing application, normalization is not that much critical. Yes, if you get into that topic of normalization, that itself is a separate topic on its own, database design. So let's not get into that. But having said that, it so happens you need to join multiple tables to retrieve the data. So let's get in and query the data from multiple tables. So to do that, there are joins, there are different joins. There is natural join using on class. It's all mostly related to the natural join. Then there is a left outer join and right outer join as well. And apart from that, you have unions, you have intersections. So there are different joins, but of them all common, the natural join, also sometimes it's called Equi Joins, is a very common among them. At times you might use the left outer join or the right outer join. So we'll see that what is all that about. So in a case of a natural join based on same column name in two tables, suppose you'll have employee table, and in our case department table, there is a department ID which is common, which is which is kind of a, if you look at it, it's a primary foreign key relationships will be there. For department table, department ID is the primary key, whereas in case of employee table, the department ID is a foreign key. It references the department table, department ID. So in a way, that department ID is a common column. You can link that. Similarly, here, it's a little different example. If you take employees and jobs, the job ID of these two columns, the job ID over here in the employees table and in the jobs table, job ID, you can then get the job ID. Might not give that much easily understandable description. So you might, instead of using job ID, you can always find out what is that employee or the specific employee in the, what is his job title, using the join condition. So, and the join condition is going to be the job ID. So here you will have, we get a first name as well. So the name of the employee, job ID, employee table, natural join with the joins jobs table. So this is the common column which is available in both the tables. So that is the natural join. And there is also something called as using class. If several columns in the same name but data type do not match, then using class specify the column for the Equi join. So use the using class to match only one column with more than one column matches. You can use the using joins. So in this case, this is what I had discussed earlier, the department ID. We use the department ID because in the employees table, it's a foreign key, whereas in the department table, department ID is a primary key. So what we'll do is, this is a join condition. So we'll take a natural join and we'll start off with the demo. Let us now run through the examples or the demonstrations for the natural join or equi joins, in which case we'll be using a couple of tables to retrieve the data. The first one is the natural join. We are retrieving the employee ID, first name, job ID, job title. And in case if you want to have a natural join, then the condition is the join column, specific column should be of same data type. Then in that case, yeah, same title with the same data type, then it will get retrieved. Here we are using job ID. So that will be the condition of this natural join. So if I run this, yeah, it retrieves the rows that has the employee ID, first name, job ID, and the job title. But using, as discussed, in some cases, if the natural join might not work, if the data type varies, the length varies, even though the column title may be same. So in that case, yeah, you need to tell that what is the column you are going to use. And here we are, instead of the jobs, we are using the department table and enforcing the SQL query to use the department ID. This again, when the data type is going to be different. So we get the values. This is between the department and the employees. Earlier we saw with the employees with jobs, and this is with the employees and department. There is one more approach which is generally called Equi Joins, and this is what once you get experienced over using the SQL, the most common one is we keep using the Equi Joins, wherein this is the from table. You create one, give the alias name, and you mention specifically from which table, which column. A dot meaning A is employees, and A dot last name is again employees. B dot location is from the department table, and B dot department ID is again from the department table, and this is the join condition you got to mention. This is an equi join. So let's quickly run it. So you get employee ID, last name from the employee table, the rest is from the department table. Similarly, this is for the jobs. This is similar to this one, the natural joins, but here, I mean, it will be the same result as the natural join. Though it is equi join, we use the same job ID column to link both the tables and retrieve the data. So you get the same result as the first one. So this is the natural join or equi join. If you want to enforce, then use the using class. So as I said, yeah, it's based on convenience. I generally use the equi joins to retrieve the data. We use the alias name plus then the join condition. We'll progress further. Thank you. So another type of joins sometimes you use is the self join. So in the employee table, you have the employee ID and the manager ID as well. So in that case, what you need to do is you need to join with that employee table itself to get the result. Because what we have is the employee ID is there and then the manager ID is there. But if you look at the names, they belong to the employee table itself. So basically you need to have a join on the same table itself to derive out the result. For example, I want, instead of the manager ID, which is again a kind of an employee ID, if I want to have the name derived out, so in that case, yeah, you need to have a self join and derive out the that's where if you look at it, employee last name, and then you have the manager last name, and you have the join condition. And similarly, employee last name and the manager last name. So this is the alias, and this is the alias, and this is the table. So basically, you are trying to use the same table is used, and you have used the alias over here, and you are trying to retrieve out the details. So let's now run this query. I mean, it's pretty straightforward. All that is required is you're joining the table with itself and getting the required details. So stay tuned. Let's quickly run that in the Apex SQL command. So I have copy pasted the self join condition, where we have the again, it is the same table. EMP is mentioned here, so I'm referring the EMP over here and the manager ID, and manager dot employee ID. Though it is the same table, we are performing a self join and thereby getting the employee name as well as the manager name. So when we run that, yeah, we get the result. So this is about the self join, which is basically you have to use that to get the relevant data from the same table itself. So we will progress further into the other joins in the next presentation. Let us now look at yet another join condition. The most, I would say, not complicated, but totally people generally get confused with this join, which is the outer join. Particularly, people tend to get confused between the left outer join and the right outer join. So before that, yeah, so far we have seen the inner joins, which is basically like we retrieve the matching rows between the two tables. We combine the two tables with the join condition, and only the matching rows is retrieved. So that is an inner join. Inner join finds and returns the matching data from the table, and the inner join focuses on commonality between the two tables. And if you get to outer joins, it is something like two tables. From the two tables, you get the commonly available matched rows. Additionally, whichever is unmatched also, that needs to be returned as well, the unmatched rows. And that is where you have a left or right. If it may be left outer join, when it is the left side of the table unmatched rows are retrieved, and right outer joins where the right table's unmatched rows are returned. So that is where it has the left or right, and similarly the left or right. So left table's unmatched rows are returned, then it is left outer join. Right unmatched rows from the tables are returned, then it is the right outer join. Finally, there is one more join, which is a kind of a outer join, full outer join by itself. So it basically returns the results of the inner join as well as the results of the left and the right. So unmatched rows from both the tables are returned, then it is full outer join. Hope it is clear. So it is left outer join, right outer join, and full outer join. The left outer join, all the inner join rows plus unmatched rows from the left table, then it is left outer join. If it is right outer join, then right table unmatched rows needs to be returned. You'll understand clearly as we get into an example. So from a syntax perspective, this is how it will look. So you can mention as left outer join or these through join condition. Otherwise, you can add a plus sign over here for the left outer join. So which basically we are trying to match the department ID. You might be in a case you have an employee, but you don't have a department assigned to that employee. So in this case, so unmatched rows in the left, say for example, if it is employee with name A doesn't have any department assigned, that is going to come up in this query. So this is the left outer join, unmatched rows. Right outer join, you could have a new department, for example, new department which is just incorporated recently. You don't have any employees in that department assigned, then that is the right outer join. So, and you can have a full outer join wherein unmatched rows of employees, unmatched rows of department will get fetched. So, I mean, we'll see that in the example. You'll understand with clarity. Thank you. Okay, let us now run the sequels of the outer joins in the SQL commands and see what we get. So this is for the left outer join. So employee tables. So grant, if you look at it, the last one, grant, doesn't have any department assigned. So maybe a new employee, no department. So you have grant also been retrieved or selected. Similarly, an alternative is that you can use the plus condition as well. So the results will be the same. You have grant is there. So this is the left outer join, the left side of the table, which is the employee table, unmatched rows has been retrieved. So that is the left outer join. Now we'll go to the right outer join. That means whichever unmatched rows from right side needs to be fetched. So whichever, if there is a department without any employees, that needs to be retrieved as well. We start OEHR, EHR. So all these department, though they are there in the defined in the department table, there's no employees. So naturally it is unmatched. So that is returned as well. Similarly, the same one, you can have the plus indicator and have the result. And finally, the full outer join. So which means basically the join condition satisfying, even which are unmatched, even gets picked as well, or that gets retrieved as well. So this is, so here after making correction with OEHR, you will find we found grant was not having grant so here is one grant, so who doesn't have a department assigned. So this is being an outer join, grant is received, and it also fetches all the department, wherein there is no employees assigned to it. So that is gets returned as well. So that is the outer join where unmatched rows from both the sides of the table is also retrieved. So by this, I hope you have a clarity as what is an inner join, what is a left outer join, what is a right outer join, and what is a full outer join. So thank you. Stay tuned. Welcome back. Let's now look at another interesting and important topic, which is subqueries. So far, we have retrieved from a table, single table with functions, with particularly the analytical functions, and then we went on to see about the join conditions to retrieve data from multiple tables. Now, in certain cases, you need to have a subquery. So what is a subquery? So for example, if this is a question, let's see, there is an employee called Kochar. So we just wanted to know who are the employees who are hired after Kochar. So in that case, we need to first derive out when was Kochar hired and what date. Once you get that information, use that information. So that will be a kind of a date information. So that date information, you pass it on to the parent query or the main query, and then it's just going to be the date whoever has hired. After that date, you got to retrieve all the employee names. So this is how it's going to look like. The last name where hire date is greater than, so this part of the query is going to get you a date value, return date value. If you run the separate query, it will get a date value, and this date value is being assigned the sense you have a comparative operator greater than, so greater than, hire date is greater than that specified date. It lists out all the employee in hire date. So subqueries sometimes you need to combine with the joins. So this is how the subqueries work, and sometimes in this case it is going to return a single value. In some cases you may have a situation where it will return multiple rows subquery and then subsequently use that in the main query to fetch the relevant data, just like what we have seen here. And subqueries, single row subqueries, yes, we saw like greater than or equal to, I mean, all the operators you can use, particularly like this one, gives a single row and then use that single row to retrieve the multiple rows. Then let's quickly look at a condition, maybe a quiz. So what will happen in this query? What we are doing is we are getting a minimum salary from employee group by department ID. The first question is whether it is going to be a single row or a multiple row. That's the question number one. So if you look at it, if there is no group by, because there's a group by, so it is going to give for all the departments, it is going to get the minimum of salary for all the departments. So in that case, it's going to give you multiple rows. So this query where salary equal to, you have multiple rows, so naturally what will happen? It's going to throw an error, single row with multiple query. Whereas if you don't have this statement, if you don't have the group by class, if group by class is not there, then from all the employees, it is going to return only a minimum salary. Then yes, you have an equal to operator. So the minimum salary, just like what we saw in the hire date. So when you pass on the hire date, then you say greater than or equal to and retrieve the rest of the all the values. So that is the wrong one here, and it is very common. A single row subquery returns more than one row. This is a quite common error you come across when you start using SQL as a subquery. So keep that in mind. And similarly here, yes, it should not give you any problem because we are getting a job ID whose employee number, employee ID is 141. For that we are getting the job ID, and job ID select last name, last name job ID from employees where job ID equal to. So the point is just a repeat. So whenever you have a multiple rows and you have a operator over here, then you get single row subquery returns more than one row. So that is going to be the error message you are going to get. So that's about the subqueries. So we'll continue further. Stay tuned. Thank you. Let us now look at the subqueries. So from the presentation, I copy pasted all the queries select statement. So if you, the first one is of course to find out the folks who have hired after coach-r, the employee coach-r was hired. So to do that, it is two part. First is to find out the hire date of coach-r. Again, if you look at it, it returns a value like this has returned a value as 26 November 2008. So basically it is something like replacing the entire thing with 26/11 of 2008. So whoever has been employed after 26/11/2008, That is what it is. This one is going to return. So if you run this, and if you look at the higher dates, all of them will be after 26/11/2008. The most earliest one is by name Mr. Hunald. It's on 10th March 2009. So that is one. And this one, if you look at it, this one will return the second part. If you look at it, this will return, because you have a group by, this is supposed to return multiple rows. Since salary equal to multiple rows, that is where it gets a problem. And you'll get an error as the single subquery returns more than one row. So to do away with that, what you could do is, remove the group by. Then that means it is going to fetch only the minimum salary of the entire employee table. There is no group by at all. So if there is for the minimum salary, if there is equal to, which is basically again it is going to return the same one also. So instead of that, if you put as greater than, then it is going to return many people or many employees. These are the employees who are greater than, and you have more of them also, because minimum salary, you will have many of them who is more than this salary. So that's the way you work through the subqueries, which is also common, I mean, in any kind of, whether it is the query you're trying to do it in a reporting or in a data warehousing system, subqueries also plays a critical role. Thank you. So far, we had looked at the user created objects, but Oracle has its own objects towards maintenance of the database, and that is maintained through the data dictionary. So one is that if you look at it, you have the user created objects, tables, views, and so on, and then there is also data dictionary. I mean, this is towards maintaining the database plus the user created object to work efficiently. So user tables, or the tables created by user, contains business data such as employees. There is another set of tables views in Oracle database known as data dictionary. This is created and maintained by Oracle DB or the server or the instance, and contain information about the database. Only the DB process, we have seen various DB process like database, DB writer, SMON, PMON, we would have seen that initially. So those are the database process that will write and read from these tables. Yeah, you can read this table, but you cannot and you should not, by in any case, write on those table, which will cause data corruption. And the Oracle user sys owns all the base table user access views of the data dictionary. And you have different prefix. One is the user view, what is user schema and what is own, all user view, and DBA. These two are specifically related, I mean, for the database administrator activity. The last two are used by the DBAs, but generally, as you advance in the development process as a SQL developer, you will start using all these data dictionary tables, that is as the prefix as user underscore, and you have all tables and so on. So here is just an example. I went into the SQL command and then describe user objects. It has object name. So whatever the user created objects will have an entry over here, object name, like OE, HR, all this will be there. So I just ran a query from the data dictionary object, that is user underscore objects. So I retrieved the object ID, object name, status from user object, where object name OE, HR, employee. There are two. One is that if from the name itself you see there is a sequence. There is of course this table object OE, HR, employees are there. So object, I think object type should also be there. in this table, object type is there. So if I include object type, then it should give me what object type it is. Source object type, comma, status. If I now clear this, so just rerun the query. So if you look at it, this is OEHR employee, the object type is table, whereas this one is a sequence and both are valid. So this is again, if you look at it, this is a data dictionary object, user underscore objects, and it is whenever you create a new object, it has an entry over here. So that's about the data dictionary objects, which is maintained by Oracle itself, Oracle database itself. Thank you. Stay tuned.